Okay, so welcome back. Today's lesson will continue down the path of looking at chemical bonding. The idea that unstable atoms will do things to rearrange their valence electrons, look for that thing that we call octet, or the same arrangement as a noble gas would have in group 8A, um, and form something more stable called a compound. And then when a compound forms, we have systems for trying to name some of those new things so that we suggest something new has formed. So for example, when sodium and chlorine join together, they can form a compound that gets a new name. It's called sodium chloride, which you might know as table salt. So we'll be taking a look at ideas that relate to the naming of a specific kind of compound in today's lesson called covalent compounds. And it will only apply to binary style. Binary means made of just two elements. So let's get right underway with our lesson for today. Okay, so we see here that we have what we call binary chemical compounds, compounds made of just two elements. Well, there's a naming system that is very similar for both ionic and covalent compounds. In fact, they follow the same rules. We will see how those rules are actually very similar. We've already named ionic compounds, so we're going to notice that there's a very similar way of naming covalent bonded compounds. So ionic bonded compounds, when it begins with a metal, we have ions. The metal gives its valence electrons to a nonmetal. We get a cation that forms, an anion that forms. They lock together because opposites attract, and we get what we call an ionic bond. And the name of the cation followed by the name of the anion just becomes the name of the compound. We have something very similar for naming a covalent compound. The only change is that sometimes we use prefixes. And prefixes are used to suggest quantity. And some of these prefixes you may recognize maybe from study of ideas that relate to geometry. For example, hexa. Hexa means 6. Penta, like the pentagon. Penta means 5. Prefixes are going to be used sometimes to suggest quantity. You're probably even aware there's a chemical called carbon dioxide. The prefix di suggests quantity. So let's get right underway with ideas. So first of all, most of today's lesson is going to focus on the blue side over here, covalent compounds. When covalent compounds form, we have only nonmetal atoms, and the names of the nonmetal atoms help us understand some relationship between the way the compound is named, and we'll be taking a look at that. One difference when we have covalent bonded compounds is covalent bonded compounds make what we call molecules. They never make what we call ions. And what we recently learned is those molecules could either be polar or non-polar, and that will have to do with what the electronegativity of each element is that participates. But that's not really part of today's lesson. So the rules for naming every binary compound, every compound made of just two elements, are the same, whether it's ionic or it's covalent bonded. The first element keeps its full name. So if the first element is the element sodium, it's called sodium. If the first element is carbon, it's called carbon. The second element uses the same rules. There's a root word, and we looked at those root words already. They're right here. Root word hydrogen, hydge for hydrogen, bor for boron, carb for carbon. So the root word is followed by ide. So carbide, silicide, boride, iodide, chloride, oxide, so on and so forth. The only variation we're going to add to that today is when we have binary covalent bonded, not ionic, we add prefixes, and prefixes tell us quantity. Very easy naming system. I wish all chemical compounds could be named this way, but the truth of the matter is most chemical compounds are made of more than two elements, so this wouldn't work in most cases. So here's how it works. We think about the two nonmetal elements that are joined as being two different parts. So it's almost like in our mind, we isolate that there's two parts, right? Carbon and oxygen are our two elements that are joined. Think about it as two parts. Next thing we do is we think of the first part as needing a prefix only if there's more than one. So here there's no number after carbon, so that means there's only one carbon. There's no little subscript number after the C here. So the first part is simply the element name. There would be a prefix if there was more than one atom of carbon. Since there's not, no prefix. Okay, so first part, that's the way we look at it. Second part, we always add a prefix. So the prefix is related to the quantity. And we're not going to memorize the prefixes. We're going to look at a chart that suggests what they are. So the prefix for 2, when we look at the chart that you're going to be using, right, the prefix for 2 happens to be di. So the second part, we're going to add that prefix only if there's more than, the second part, we're always going to add the prefix. So even though here there's only one oxygen, the second part gets the prefix for 1, which is mono. So then we follow it with the root word for oxygen, right? When we look at our chart, the root word for oxygen is just ox, and then it always ends in "ide." So monoxide, carbon monoxide, better pronounced as carbon monoxide. So typically what happens is sometimes there will be a double vowel sound that sounds very unnatural. So if we get double O, drop off that first O. It'll flow more naturally off the tongue then. So we won't say monoxide, we'll say monoxide. Likewise, if we had the A before the O, we'd drop off the A. And like if it were pentaoxide, we'd just say pentoxide. Okay. So let's look at this second example. The first part is just the element carbon, so no prefix, carbon. The second part always gets a prefix. Prefix for 2 is di, right? It's the element oxygen, so it uses the root word for oxygen, which is just ox, and then we add "ide" to the end of it, carbon dioxide, a chemical that most of you have heard of before. Maybe some of you have heard of carbon monoxide as well. So it comes from a naming system. This naming system works for binary covalent bonded. It means it's made of just nonmetal atoms. Okay, let's put this to use. So this chart, we're going to have to learn to refer back to the chart. We're not going to memorize it. If we used it over and over, you'd probably remember most of them anyway. You're going to find that you're familiar with most of them to begin with. For example, tri means 3. Yeah, anybody ever played the video game called Tetris? There's 4 little blocks that fit together and make one large piece. You're supposed to fit them together at the bottom of the screen. Tetra means 4, penta means 5, so on and so forth. So refer back to quantity, the prefix quantity chart here. Refer to your root word chart, right? Hydrogen, hydr, boron, bor, carb, right? Nitr, ox, fluor. Let's put it to use. So here we are, we're looking at, we have the chemical formula made of 2 nonmetal elements. We want to turn it into the chemical name. So here's what we said a moment ago. The first part is always the element name, and it will get a prefix if there's more than one. Isn't there more than one here, folks? There's 2 nitrogen. So the first part here, we're required to use a prefix now, the prefix for 2. When you go to look that up, right, you're going to find that that's found in a very specific place, right? The prefix for 2 is di. So we're going to use that prefix, dinitrogen, right? First part's the element name. It gets a prefix if there's more than one. In this case, there is, so we say dinitrogen. The second part always gets a prefix. So the prefix for 4 is what we're interested in. Looks like the prefix for 4 is tetra. So tetra. Then we're going to use oxygen because the element is oxygen. We just use the root word, tetraox, and then it ends in ide, tetraoxide. Well, it sounds unnatural, the A before the O, so we drop off that A and just say tetroxide. Dinitrogen tetroxide. So that double vowel AO or OO, we're going to eliminate that first vowel to make it sound more natural. Dinitrogen tetroxide. Okay, let's take a look at a second example. Again, first part is the element name. It gets a prefix only if there's more than one. In this case, there's only one S atom. So you see there's no number after S. So we'll just say sulfur. No prefix because it's the first part. Second part always gets a prefix. Well, the prefix for 6 is hexa. And then we're going to add the root word for the element fluorine, fluor. And then we're going to end it in ide, and we're going to put that all together. And we're going to call it sulfur hexafluoride. So the prefix for, the root word for the element, the "ide" suffix, hexafluoride. So let's apply it to another example, right? So first part gets a prefix only if there's more than one. Look at that, folks. There's only one nitrogen. No prefix required now. So we're just going to say nitrogen. Second part always gets a prefix. Prefix for 3, just like in baseball, triple, tri. Triathlon, 3 events. So tri, root word for hydrogen is hydr, ide suffix on the end, trihydride. Nitrogen, trihydride. One final example in this form. So we got the elements boron and chlorine. First part is the name of the element. Gets a prefix only if there's more than one. Only one boron, so we're just going to say boron. Second part always gets a prefix. Prefix for 3 is tri. The element is chlorine. We're only going to use the root word chlor. We're going to add ide, put it all together, trichloride. So boron trichloride becomes the name of the compound. Remember, these are for binary compounds, compounds made of just 2 elements. I think it's easier to do it in the reverse, folks. So here we got reverse, reverse. We're going to do it the opposite way. Carbon disulfide. So carbon, look, there's no prefix in front of carbon. Guess what they're suggesting? That's right. There's only one carbon. Disulfide. Di means 2. Sulf means the element sulfur. Ide is the prefix, the suffix that it always ends in. So 1 carbon with 2 sulfur is carbon disulfide. Another example, dinitrogen. Look, now we got a prefix. That means now this first part has more than one. So dinitrogen means 2 nitrogen. Heptaoxide or heptoxide. Notice we dropped off. Hepta is the prefix for 7. So if we look at our prefixes, here's hepta. We dropped off the A because it makes it sound unnatural. And we say dinitrogen heptaoxide or heptoxide. Heptoxide sounds a little more natural. So N2O7, the quantities are suggested by the prefixes. Final example in the chart, penta, the element phosphorus. Penta means 5, so 5 phosphorus. Decoxide, so that means deca means 10, right? A decade, 10 years. So decoxide, that's the element oxygen, 10 oxygen. So if you want to have a little fun with this, what you can do is you can kind of goof with someone about this particular chemical here. So if we wanted to name this, you all recognize this as water. Well, what we could say is we could name this as its systematic name. The systematic name would be di, because there's 2 of the element hydrogen. So we'd say dihydrogen. Not very good at this writing tool here. Certainly doesn't help that use a crummy mouse pad. Dihydrogen. And then prefix for 1 is mono. So we'd write mon, right? It's the element oxygen. So we'd use the root word ox. We add ide to the end of it. Dihydrogen monoxide. It's the systematic name for water, folks. You want to have a little fun with that? Go tell someone about how worried you are about the massive quantities of dihydrogen monoxide found in our water supply. There's just a plethora of that dihydrogen monoxide found in our water, and I'm real worried about that. So dihydrogen monoxide, it's actually the systematic name for water. So systematic names are much easier to use because they tell us quantities. Water is just a common name. I don't really prefer the term water because it really doesn't tell us anything about what the compound is made of, and it doesn't specify quantity. So if we want to replace it with something a little bit more systematic, sounds a little more appropriate, dihydrogen monoxide. So that wraps up our lesson for today, folks. Your assignment will be to practice some of this chemical naming. When you go to do that, recall that you'll need to use some tools. So those tools I'm not asking you to memorize. One of those tools will be, see if I can activate this again. One of those tools will be the chart of prefixes, mono, di, tri, tetra, so on and so forth. The other tool will be the root words for elements. So until the next time, folks, I bid you peace. Good luck with your assignment today.